Hey, happy Sunday. This is PFG Live, the podcast that asks you to get flat, stay flat, and figure out why you got that way. Welcome aboard. We've got a bunch of people in Discord and some people on YouTube. They're coming in the back. You could just take seats in the back of the room. It's okay. Evils is with us from Belgium, in which he is reporting temperature 27, dew point 11.9, relative humidity 42%. And he's amazed that his sensors worked. Here in the Windham, New Hampshire, it's 69 degrees, 60% relative humidity, and winds are light. Ted from, where are you? You're in Kilo Lima, Echo, Echo. He says winds are 140 at 4 knots, visibility 10 miles, scattered at 4,000, temperature 31, dew point 23, with Happy Father's Day in the remarks. I have to ask Ted, was that the actual remark in the, or did you add that? I need to know. Because if it was in the remarks, it was added. Okay, fine. I would have had more respect for the FAA if they put it in. The Manchester airport up the street is reporting variable winds at 5 knots, visibility 10 miles, scattered at 3,600, broken 13,000, temperature 20, standard, dew point 11, altimeter 3017, with assorted remarks. Who else we have? Tucker in Buffalo, New York, reports 76 degrees Fahrenheit, sunny, and no buffaloes. Kyle says it's 64 degrees Frankenstein, going up to 79 today in Salem, Oregon. Welcome aboard, sir. Chris O. Chris says, he got bumped off the screen, 77 Fahrenheit and sunny in Los Angeles, California. Thinking of you today, Chris. Josh says 42 degrees. I can't read it. It's 42% relative humidity with 23 degrees. Excellent. Robin says mist 1 notch above fog. Wow. If you can't see your hand in front of your face, you have to ask, why are you staring at your hand? Let's see. CJ Stevens is reporting 81 degrees and trying to rain in East Tennessee. Welcome aboard. He also says Happy Father's Day, and Happy Father's Day back at you, sir. And Happy Father's Day to everyone. It is Father's Day, so I expect we might have a light turnout today because of all the Father's Day activities. Let's see. Engineer raised in Kingston says 23 degrees science, 34% relative humidity, unusually sunny in the London of the UK. Welcome, sir. Carl Tauber says it's 68 degrees standard and cloudy in the People's Republic of Rhode Island. Welcome, Carl. So I'll call him as I see him come in. It is a pretty nice day here. We were doing some outside work, getting ready to have power washing done tomorrow. And it was just gorgeous outside. Take your allergy meds if you're of that persuasion, though. I'll tell you that. Let's see. Who else is coming in here? So it was a good, a busy week. And you'll have to forgive me. I'm going to tell a story that is in a little bit of a generality because I don't have permission to give details. But I had a project that we've been working on for quite a while. You guys have seen pieces of it that involved laser cutting and all that kind of stuff. Well, we're into the electromagnetics now, building the thing, measuring the thing in the lab. And I think it was Friday night. I'm desperately trying to get this thing finished for my client. And it's, overdue. And I get onto the electronics bench and I start doing measurements, and there was a particular measurement just looked terrible. I'm like, what's going on here? And basically we lost 4 dB somewhere. Now 4 dB doesn't sound like a lot, but in terms of power, that's 3 dB is a half or a doubling of power. And we lost 4 dB somewhere. And I'm racking my brains coming up with theories as to how this thing could have failed, but I was just crushed on Friday night. I was really upset. So I walked away. I said, "Going to bed. See ya." And then I went through my head all day Saturday, and I'm trying to figure out what the heck is going on here. So then I came up with the plan. When something like this happens, and you get into a situation, you have to stop, reset yourself, and approach it again. And that's exactly what I did. And this morning, I walked into the lab like I was never there, fired up the instruments, let everything warm up, and I went ahead to repeat that measurement. And as I was calibrating the instrument, something was weird. So I decided to back up a little bit and do a measurement on a sort of a self-check on the instrument, and I had an instrument problem. So the next time you go, you're measuring something, you're measuring the length of a critical thing you're machining in the shop, or you're on the grinder, and all of a sudden it's like bad. Stop, recalibrate your instruments, double check your procedure, and see where you're at. Well, that's what I did, and it turned out that my long-term magnificent vector network analyzer was misbehaving. Now, when you have an instrument that you depend on, you should always have two. So, of course, I have a second one. So I fired up the second. In fact, it was kind of funny. I talked to my instruments. I looked at the second one and said, "Okay, you're on deck." Fired it up, got it going. It's about 30 years newer, and what do you know? Everything was working fine. So all those antacids were, not a good investment. Dale says, "Sorry, I'm late. I have a very good excuse. It's 20 degrees science standard and sunny in the Canada." So Dale, of course, is up in Edmonton, Alberta, and having a good time. He sent us pictures, by the way, of the dim sum that he's enjoying in Edmonton, and we all want to go. So welcome aboard, Dale. So the long story short is you fire up the backup instrument, and everything was fine. So I proceeded to take a bunch of data, talk to my client. We all just breathed a sigh of relief, and now we could proceed ahead to finishing this project. Of course, I have an instrument now that's unwell, 8714C. I really like it. It was the first instrument that my business bought, and it's been working all these years. So that was a story in the lab this morning, and I don't know, maybe one day. Yeah, Robin says, like picking up the wrong probe that isn't connected. It was almost exactly like that. Okay. Thank you, Ted. Mark at Curious Mark. We need to talk. Let's talk. I got a reference to somebody who was doing instrument repair, and but if Curious Mark, okay, I have to talk to Curious Mark. Ted says he loves his HP Agilent Keysight stuff in Legacy. We have to talk because I love the 8714C, and it has been a rock the whole, all these years. And just for completeness, the instrument that, was working this morning was my, it's an Anritsu. It's called a VNA Master. I forget the model number, forgive me. It goes to 22 gigahertz, and it's portable. It's actually battery operated, which sounds like a feature. I don't use it in that mode very much, but good instrument, and it was working. Whew. So that lowered my blood pressure this morning, and that was good. So I was pretty happy. Yeah, so that was this morning. It is Father's Day, and there's no better thing to do on Father's Day than to enjoy your family. So everybody who's not here, we're at about, I don't know, half capacity today. because of Father's Day. I know I took Mother's Day off because I had to be somewhere, but here I am. We have a McMaster car catalog giveaway that has been open for 2 weeks. If you have submitted the form, then I have your entry. And we don't have a ton of entries, but we have enough to make this make it a good time. So let's get this done. I'm going to bring in Iron Man. Let's see if he's there. Iron Man, can you hear me?
Yep. Yes, I can.
There he is. Okay, so you're going to help me out here today. We're going to use, we're going to use random.org, and I need you to pick a number between 1 and 5, and that's how many times I'm going to click that button, and then whatever number is on the bottom there, that's going to be a winner, and we're going to repeat this 4 times. Are you ready?
Yep.
Okay, give me a number.
4.
All right. Click. Oops, I'm clicking in the wrong place. Click, 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 and 17. Number 17. So let's see. We go over here to, where are you? You're right there. Go over to 17, and that is Kyle Nickel. Kyle Nickel, you have won a McMaster car catalog. Congratulations. And I am highlighting your name.
And the crowd goes wild.
The crowd goes wild. So, Kyle, if you're listening to this, just send me your mailing address. It will be going Media Mail, USPS. Okay? Okay, you ready for another one?
Yeah.
All right, stand by. Put the whiteboard up. Give me a number, 1 to 5.
Let's max it out. Let's do 5 times.
Okay. 1, 2, 3, 4, 5. The number is 15, and 15 is this guy. I don't know if this is legal. Okay, it's this guy named Tucker. Actually, it says Tony Stark is the name on the thing. Okay, Tuck. I don't think anybody can claim that you had any influence on this, but you get a McMaster car catalog. All right, here we go.
I'll be sure to send it to Mr. Tony Stark himself.
All right, give me a number between 1 and 5.
Somewhere between 1 and 5. That's got to be 3.
1, 2, 3. Number 19. Okay, let's see who 19 is. It's Argyle. Argyle, you win. I'm going to highlight Argyle. Boom. We got to do 2 more. All right. Go ahead. Pick a number between 1 and 5.
Let's do 4 again.
1, 2, 3, 4, and the number is 18. And that would be Arsted. David, you have won a McMaster car catalog. And I think that's 4 of them. And that's how many catalogs we have. We're done. So the winners are Tony Stark, Kyle Nickel, David Arston, and Argyle Amberson. Now I have to read you a couple of things. On the entry form, it said, "What is your quest?" You had to answer that question. And one of them was just hysterical. He didn't win, but Nathan wrote, "My quest? To seek the sacred texts, a legendary tome rumored to be given out to only the most dedicated of tinkerers, the fabled McMaster car catalog." Well,
that's awesome.
And then let's see. Dan said his quest is perfect threads. Tony Stark said his quest is peace in our time. I don't believe it. He sells weapons. Let's see. Chris O said the Holy Grail, which is, of course, the correct answer. But Kyle said to make all the things. David said to seek the holy catalog, and Argyle said to seek perfect flatness. Excellent job. So you guys are in. I'll take care of you. We'll communicate. And that concludes our McMaster Car catalog giveaway. Thank you for your help, Iron Man. I'll send you
Have
back.
a good one.
Go back out into the ready room there. Don't eat all the finger sandwiches. All right.
Bye.
You have to kick yourself out back into the audience there, bud. Okay, we did it. McMaster. So those are going to be coming media mail, USPS in a 10 by 8, 8 by 10 by 6 box. I think that's the right size. Or is it 12 by 8 by 6? I think that might be it. Okay, so another thing came up this week. I was talking to, I was talking to John Grimsmo, but the topic was using resin bonded diamond wheels. And I wanted to just review how I picture and the rules I use for resin bonded diamond wheels. The good news is that they're not that expensive. You could buy a brand new one from like Norton for $50-$60, I think. You could buy Chinese ones. Well, you used to be able to buy Chinese ones on Amazon for cheap. I don't recommend getting the super cheap ones because you don't really know what you're getting. And if you do get one off of from Norton, it'll last a long time. So basically, when you get a resin bonded diamond wheel, what you're buying is a bunch of diamonds of a certain grit, and they are in a resin. Like you could think of it like an epoxy resin, and that resin is applied to the rim of a wheel. It could be aluminum, it could be steel. Generally, it's aluminum for the resin bonded wheels. And to get it ready to work, that's right. Dale says or plastic. I guess there were some that are now plastic, which is okay. I'm not judging. So you have to do all the usual things for a grinding wheel, okay? You know, when we mount the grinding wheel, the first thing we do is we ring it. Now, you do that to make sure it's not cracked. Of course, the resin bonded wheels that are aluminum are not going to be cracked, but you basically are going to make sure that it is in mechanically sound condition. Dale says that he's using 14-inch because he has a huge grinder, 14-inch plastic cord resin bonded diamond wheels, which is pretty cool. So you get the thing, you get your hub out, you mount it to your hub, and the smart thing to do at that point is to use a hub that allows a little bit of play on the hub, and then use an indicator. I'm not going to get into detail here because there's a bunch of ways to do this. Use an indicator to get the thing centered as best you can. The next thing you're going to do is you're going to tighten up the nut on that, and you can use a modified nut, as Robin taught us, which I do use on the wheel. But basically, you're going to tighten it up on the hub, tighten it good so it doesn't move around. Robin says some aluminum wheel bodies are resin bonded aluminum powder and they can crack. Okay, thanks. I've never seen one, but that's interesting. All I've seen is turned aluminum discs that have the bond on the periphery. So the next thing you're going to do, just like with all wheels, is you need to true the wheel. So this is the part that there's a bunch of ways to do it. There are these devices called the Norton truing device that uses a brake controlled truing device that uses a small aluminum oxide wheel at a reduced surface feet per minute through its little braking action, and you run that over the wheel a bunch of times and you get the thing trued. Now, in my opinion, uh, after truing, I would mark the spindle, I would remove the wheel, and now I would balance it. And you could argue, oh, you could have balanced it beforehand because you're not really moving much material. You could do it that way also. That's a religious argument. I won't get into that. But you need to balance the wheel. So there's a bunch of ways to balance it. Oh, there's a picture. Dale put a picture of the Norton brake-controlled truing device in the chat. You need to get the wheel balanced. Also in that picture, by the way, if you look at the hub at the upper right corner of the picture that Dale just posted, that is a 3-weight sliding balancing arrangement. So you could use you move the 3 weights around, or this is a commercial. You could buy a B200 balancing ring. It goes onto the small Sopco hubs that are very, very common, and use the number 8 BS8 balancing stand from Kinetic Precision, which is an under $200 balancing stand to help you balance your wheel. Okay, after balancing, after truing comes dressing. So if you imagine that you just have a freshly paved road, right? You've got all this asphalt with all your gravel in it, and the steamroller just went by. That's what you have now. But you need those diamonds sticking out of the resin in order to do their job. So now you're going to come in and dress the wheel. And for that, we use an aluminum oxide stick. So you could use, this might be sacrilege, but you could use almost any aluminum oxide grinding material. But they make these relatively high friability, very soft sticks that you with coolant preferably you jam into the wheel, and it will abrade away the resin. Okay, in our analogy, that's the asphalt, and basically let the diamonds stick out. It should not hurt the diamonds, but it will abrade away the resin. And now you got diamonds sticking out of your resin. You've balanced, you've trued, you've dressed. You're ready to work. So those are the steps you have to go through to get a diamond wheel ready to go. It sounds more complicated than it is. It actually goes pretty quickly. Now, for truing, I use molybdenum sticks, and I sell molybdenum sticks on the website. Part number Molly-2. It's a 2-inch long piece of molybdenum, 99 point some high number, pure molybdenum. And you have to lower the speed of your wheel in order to use it. I forget the exact numbers, but it's on the website, pfg.gg/Molly, and it'll tell you all about it. You have to lower the wheel, and that will let you true the diamonds. And in a fashion that's similar to the way that the truing device does with the little aluminum oxide wheel. But basically, we're knocking diamonds out that are errant, that are sticking out, until we have a nice smooth surface. With the Molly, it's sticky. Okay, at the right surface feet per minute, the diamonds want to stick to the Molly, and that's how the truing is done with the Molly. So 2 different ways to do that. Okay, I didn't want to do a deep dive, but I just wanted to make sure that everybody understood that truing and dressing are totally different steps. And of course, then there's balancing and mounting. 4 steps. And that is the quick version on the resin bonded diamond wheels. They could be little, they could be big, basically the same steps. So if you have any questions about that stuff, we could talk about it in the after show, or you could send a message, and we could help you out. Metal bond diamond wheels, same thing, way more expensive and way slower to do any of those processes with, because it's bonded by metal instead of resin. So that's the difference. So that was for you guys that need that right now. So And feel free to pop any questions about that into the chat. I will try to get to that. So all of this fun stuff that we've been doing over the last couple of years has led to all sorts of different versions of flatosity, and naturally, I was tagged to make to do some lapping. So I did. I have a video on the YouTube channel, which is preparing for precision hand lapping, and basically getting the tooling, getting it going, and actually doing the hand lapping and making the measurements using a optical flat and a monochromatic light source. So I was approached to do a 3-inch platen. Now, I had been making a 3-inch toolmaker's flat very successfully, and I had lapped that successfully. And I had a client that says, hey, we have 3-inch platens that we need reconditioned. So they came to me, and we developed a recipe for doing that. And in fact, we did that, and it was very successful. And there's video on that and Instagram stories, and I think we've talked about that before. So my client says, okay, you passed the first test. Now we have a 6-inch thing that needs to get lapped. So the difference between 3 inches and 6 inches sounds like a factor of 2, but it's actually more than that. It's like the area is a factor of 4. It's a much bigger deal. So I started working on tooling up for these 6-inch parts that need to get lapped. Well, if you're going to lap a 6-inch part, you need a bigger lap than the part. And so I decided I would make 8-inch laps. So the first thing I did, and I posted this on Instagram, is I ordered 8-inch blanks for the laps. These are cast iron discs that come right off of the McMaster catalog. And here's one of them. You'll have to forgive me. These aren't light. This is 17 pounds of cast iron right here. So this is a 8 1/8 inch diameter, roughly 1 9/16 thick of ductile cast iron. Part number is I think it's on the links page on pfg.gg/links. It may not be, but I've published it before, and if you want to know, I'll be happy to share that with you. So this is how it comes from McMaster Car, a disc of 17 pounds of cast iron. And then the steps to getting it to become a lap, as at least the way I do it, is I put it on the lathe, and I do the edges, the periphery. I do the faces. I chamfer it, and I added something new. Let me show you. All right, so here's this is what it looks like coming off of the lathe. We bring it to a nominal 8.0 inch diameter. We do the edges, and then the last thing I do is I add a groove. So there's a 1/4 inch by a 1/4 inch groove around the periphery at the center line. And otherwise, this is just a turned disc. There's no serious magic here. This was done on the TL1 using a 4-jaw chuck, front and back, and I did two pieces. So I have 2 of these already turned. Now, the groove is there for a couple of reasons. Does anybody have any guesses? If you're hovering over your keyboard, does anybody have any guesses what the groove is for? CJ Stevens says it's groovy. Thank you. Yes, there's no bias to the groove. So that's a good trick that I've done before. Is when I make a groove, I'll offset it a little bit so that you have this permanent record of which is A and which is B. Carl says handling. That is in part correct. Yes, it is for handling the very heavy disc. Robin Tucker says to grab it. Correct. And of course, Robin knows exactly why I put it in there. It's for plastic grips. So in the past, when I was doing the 3-inch, I made, if you're on video, I made these discs that go around inside the groove on the small toolmaker's flat. And this was for handling it so that the heat from your hand is not being transferred into the lap. So we can 3D print these in whatever design you want. And there's a couple of differences in how I do this. But it's a 2-part, actually it's an identical part printed twice. And then I have some inserts and a couple of screws, and it puts together this disc that fits into the groove. The disc is for handling, and one problem of making the disc solid is that visually, when you're doing your hand lapping, it's hard to see where the edge of the lap is, and that's kind of important when you're either trying to go over the edge of the other lap or not trying to go over the edge of the other lap. You need to maintain visibility of where your edge is. So I've done like a clover leaf so that there's notches in it so that I could see the edge of the lap but still have that nice control of the plastic grip. The other important aspect of the plastic grip that goes into that groove is that it's not tight. It's loose, so that it is not sitting there putting any tension on the lap. Now, I know what you're thinking. Like, what are you talking about? This is a piece of plastic, and it's going around a 17-pound lap. It's not going to have any impact on it. A wise man once said that everything is rubber. So the answer is, actually, it is going to have some effect on it. So it is loose, but it allows you to handle it without transferring your thermal impact into the laps. So that's what the groove is for. And I have a slightly different design for what I want to try for the plastic handle. The nice thing of that is you could try any one of a number of different designs, and if you don't like them, you just throw it out and try another one. That's why we have P1. So that's the story on that. And then the next step after you take that now lathed lap, you go over to the grinder, and I grind them top and bottom, which makes them pretty much as flat as I could make them, and get them ready for having grooves cut in them. I'll show you what I mean. This one I could actually pick up. This is a 6-inch lap, and you can see it's been ground. So that surface is a ground surface, top and bottom. This one was before I put any, I started putting grooves in the side of the laps. But that one can also get a groove on it very handily. I had a very interesting experience putting the grooves on the 8-inch lap. I'm on the Haas TL1. Evil says, one step closer to offering Kinetic Precision bathroom mirrors. I don't know. I don't know if you want those, or you want to pay for those. When I was cutting the groove on the TL1, I was using the conversational programming, which I use a lot. I find it very handy. And what it does is it does a bunch of plunges with a grooving tool, okay? And then it goes in and it plunges down one wall, across the floor, and then out the other wall, and then you're finished. Well, the interesting thing was the way it was cutting with a full round grooving tool, so it's a big round on the end, is it left these two rings of material, and when it did the full plunge and then the traverse across the slot, it knocked off these two rings. I literally had these two bands in the slot that I had to cut with a wire cutter and yank out. So from a precision point of view, I would have like revisited that and said, wait a minute, something isn't right here, and those bands that are getting caught in the groove are keeping my tool from hitting the left side for the second time, the left side of the slot. But it wasn't that important, but I thought I would point that out, that was a very interesting result, that I had to get out a wire cutter to cut a perfectly complete band, two of them, from that groove. So so then we grind, we put them on the grinder, and those are 8-inch laps, the new ones, so they will just fit on the grinder because I have 8 inches in width available, and they'll get ground top and bottom. And then the final step is that they go over to the CNC mill, and we're going to put the grooves in it for the lapping material to travel in, the slurry, the diamond slurry. Now, Robin had a good idea a while back, which I definitely adopted, which was to have a moat around the outside, basically a slightly larger groove, so the material doesn't continuously run off the edge of the lap and it stays in the system. That's been very successful. Totally happy with that. So once those grooves are cut in on the CNC mill, you have yourself a lap. You have two laps. You have the working lap, you have the conditioning lap, and now you lap them together. And now you start controlling curvature. I'm not going to go deep into that right now, but basically you name one lap the working lap. That's the one that has the work put on it. And one is called the conditioning lap, that never has work put on it. And if you want the working lap to be convex, to be concave, then you put it on top of the conditioning lap and you work it. If you want the working lap to be convex, then you put the conditioning lap on top of it and you work it. So you actually have control over the curvature on the lap, and you can adjust it as needed. And then everybody is saying, hey, wait a minute, what about the 3 laps? What about the Whitworth method and all that kind of stuff? So the measurement of what you need to do to condition your lap comes from observing the work. So you take the work, you lap the work, you measure the work, you observe what's going on the surface curvature of the work, and that tells you what you have to do back at the laps to make an adjustment. Evil says, does the working lap noticeably change form in use? Yes. Yeah, it does. So if you keep lapping on it, see, one thing you have to remember is that, there's diamonds that are embedding in the lap, but there's also diamonds that are going to be rolling, as you and I talked about this week. So the lap is going to wear. The part's going to wear, and the lap's going to wear. And there's no way to avoid that. So you're continuously monitoring the curvature, the shape of the surface, and making adjustments as necessary. My point is that the optical flat that you're going to use to measure is the third Whitworth plate. Okay, so you have conditioning lap, working lap, and then you've got this optical flat that you're comparing everything to. It's not rigorously a Whitworth plate, but it is the reference. Okay, and that's the unchanging reference. So as you figured out from the thumbnail for the PFG.Live today, I needed also a bigger optical flat. So my biggest optical flat was a 4-inch optical flat, and now I have parts which are going to be 6 inches. So I decided I was going to purchase a optical flat which was an 8-inch optical flat. So that is exactly what I did. Now last week I had mentioned that I had gotten the name of an optical flat manufacturer up in Vermont called Russell Optics, and I got that name from my client. And I figured out that if you're going to, if your client is the expert and you're trying to do work for them, and they say, golly, there's this company that does really good work and they make really good optical flats, it's pretty good idea to go check out, the client or the customer or the vendor, that's the right word, the vendor that they're recommending. And that's what I did. So last Wednesday, I had called Russell Optics. I talked to a very nice person there, Elizabeth, and we set an appointment. And I said, I'm coming up to purchase the optical lab and also to visit everybody. And they could not have been nicer. So they are located in West Rutland, Vermont. And if you're a skier in this area, here's how you get there. You go to Killington and you go about 10 minutes further and you've arrived in West Rutland, Vermont. Small shop. You're going to see pictures of it right now. But as soon as I walked in and looked around, I realized I had arrived at the workplace of a master craftsman. And I did. I was talking to Robin on the phone and trying to tell him about this. It was absolutely magnificent. So let me share some pictures with you from my visit with Russell Optics, and then I will tell you some more. So I asked permission to take pictures. They said yes, and I made sure that there's nothing, no names or anything in here. This is the back room at Russell Optics. That's one of their wonderful employees working. I got to meet everybody. This is where they do finish work, edges, corners, special stuff like that. Not very obvious, but let me see if I could. There's an old Dual bandsaw, which I liked because I have a Dual bandsaw, and they don't use it very much. But there's a giant Dual there. Let's see. Then there was this is a Blanchard grinder, which, you don't always need a Blanchard grinder, but sometimes you do. So this is a really cute Blanchard grinder. It looks like it's called a number 11, I believe. Yes. Evils asks, do they saw glass on that bandsaw? And the answer is yes. There's a diamond, segmented diamond blade on the bandsaw, and it is used. Now, you said the word glass. I should point out that they are dealing with fused quartz, which, you could argue is a type of glass, but that's the material that they make the flats out of. I also asked them, by the way, who their suppliers were. They told me, honestly, I forgot the two names, but they have two different suppliers, so they have some redundancy, and they get very nice quality fused fused quartz glass that they make the flats out of. So they have this nice little Blanchard grinder. Didn't spend much time on that, and then tucked away in the back of the shop was a surface grinder that had a diamond saw on it. But in the back is this LeBlond lathe, and I was drawn to this thing, and they use it for doing edging and turning the blanks for optical flats. So they'll get a special request come in for a certain thickness, a certain diameter, and they will do the diameters on this LeBlond. Now, the proprietor of Russell Optics is Mr. Jack Russell, and he was wonderful. I have a funny story about him. And he was the one, here he is in front of the LeBlond lathe. And I said to Mr. Russell, how long, when did you start the business? How long have you been in business? And he said they started it in 1968. And he said he started in Virginia, then they moved to New Jersey, and then they moved up to Vermont. So he's been doing this for a while. And I knew I found a new friend when I said to him, gee, my folks lived in New Jersey for a while. And so I'm pretty familiar with New Jersey. And he said to me, really? What exit? And I'm like, I like you, man. So he was a lot of fun. Carl asks a question that I don't know the answer to. He says, do they use synthetic silica for UV transparency? So I presume if you needed UV transparency, they would take care of you. Okay? That's not the normal material that they do the majority of their work with. So the majority of their work is with this quartz material. But if you need it, Carl, I'll get it for you. Anyway, Mr. Russell was a riot and really super nice guy and a true craftsman. Now here's where it gets interesting. Here's a couple of art shots from the grinder. Okay, so this is a close-up, I'll back up in a second here, of one of the lapping machines. Now, the interesting thing is that this particular lapping machine had a 60-inch diameter plate on it. All of these machines were designed and built by Mr. Russell. And there are approximately 4 machines total. This was the big boy, and it was really pretty impressive. Oh yes, Evil says that's 150 centimeters. Thank you, sir. keeping me metric. But there's a great picture of Mr. Russell and the lapping machine. This is in the front office. There's a smaller lapping machine, a slightly larger lapping machine, and that's Joe. And I believe the one he's standing in front of is approximately a 30-inch plate. Now, I should point out that these lapping machines use optical pitch on the plate. So optical pitch is a liquid at all temperatures. But at higher temperatures, it gets to be lower viscosity, and at low temperatures, it's higher viscosity, but it's a liquid, which is really interesting. Optical pitch is its own discussion here, but it requires the use of a layer of optical pitch with grooves cut in it, and then I'm not going to get into the details of how these machines work, but they use a counterweight or a bruiser plate in the back, and then rotating platens in the front. So on this single machine, you can see that they're doing 2-inch. I think I'm seeing 2-inch, 6-inch, and in the back there's a 12-inch optical flat on that machine, and they keep these machines running as continuously as possible. And Joe here was a real craftsman and was running around keeping the machines happy. This is let me back up. When you go into a place that has a lot of interesting things to look at least this is how I observe myself, you go into this tunnel vision, right? And you start looking at things, and you look at the thing, and then you look at the other thing. And when you start to relax and get to just open your field of view and look around, all of a sudden you start seeing things. And all of a sudden I started realizing that's a zygo interferometer. I was just watching videos on zygo interferometers. Not only is this a zygo interferometer, that's a 12-inch zygo interferometer. It uses a laser, it uses some very clever optics, and then it uses some cameras to measure in the class of a millionth of an inch optical flats. Yeah. Evil says, what brand calipers do they use? I didn't. Now it may be because I didn't trigger on the calipers. I didn't see a caliper or a micrometer anywhere. Maybe because I wasn't looking for them. But this machine was awesome. And to answer Robin's question, when I bought my flat, did I get what are we calling it? I forgot the word, but did I get the printout? Yes, I got the printout of the for my plate of the interferogram. That's it, interferograms. And this is the machine that it's done on. It's a 12-inch Zygo laser interferometer, and it was pretty cool. So here's my plate. This was certified to, a millionth of an inch, and it is traceable. It came home with me, and let's see. You don't need to see my truck charging. Here's what it looks like sitting on my bench. So let's take a little bit of a close-up on the interferogram. You can see what it looks like. It's a screenshot of the screen that you just saw in their shop, and there is basically a topological map of the surface of the flat, and also there's a fringe diagram from the flat, and it gives you a full report. So this is tied to a particular side of a particular flat. So this is the A side of my 8-inch flat. And you'll see on the bottom right, it has a certificate number. This is a calibrated device, and it is traceable back to, wait for it, the NIST. So now if I do work for a client, and I do the same thing, I take pictures of my fringe patterns, I can relate that back to my client and say this is traceable and it is within calibration. So that was my visit with Russell Optics. It was awesome, and of course I came home with the goods. I came home with an 8-inch optical flat, and that becomes my lab standard. I can check my other optical flats against this. I can check my work against this, and I can make sure that I take good care of it because it's the one. So not only did I make a really good purchase, but I made a really good. I built a relationship with this company that has a really fantastic reputation. They told me some stories, which I'm not going to repeat, about certain companies whose names you would recognize actually send stuff to them, even though it has their label on it. And they do rework, and they do new manufacturing, and they do a great job. So highly recommended. Would recommend. 5 stars. Russell Optics in West Rutland, Vermont. Would be happy to go visit. Oh, and I did say to I did ask Mr. Russell if he would be willing to measure an item for me that I have measured, and I came up with numbers for. If I came up there, would he cross-check my measurements? And he said he'd be happy to do that, which is really cool. And then he said, you could just ship it up here. I said, there's no way I'm not driving up there. so that was a really nice offer. So we got our bigger plates. We're making our bigger laps. We are on our way. The other thing that has come up is the software that they were using on their interferograms was part of the package from Zygo, ZYGO. By the way, there's a great video on the YouTube channel Huygens Optics, which I do not have the link handy. If one of you guys want to come up with that link, which is all about the Zygo interferometer, because Huygens Optics was able to procure one for a good price, and he explained how it works, and I'm not going to try to reproduce that. But if you're curious, look up Huygens Optics, HU. Maybe somebody can grab the link. I don't remember the exact spelling. There we go. Huygens, Huygens Optics. And the title is Optical Interferometry Part 1, Introduction and Zygo GPI Layout. Great video. And it was the day before I headed up to Russell Optics. Had no idea I was about to put my eyeballs on not one, but two Zygo interferometers. They have a 12-inch and a 6-inch. So there is a piece of software out there called DFT Fringe, which will take an image of a fringe pattern and turn it into an interferogram, just like what you saw here. It is open source. I have it running on one computer. Another computer had trouble with it. I don't know why. We're figuring that out, but it works great. Yeah, Dale says if you can get it to run on your computer. So I have it running downstairs on my simulation computer, which is just it's actually a Windows 10 machine. But my Windows 11 machine has some trouble with it. I don't know why. But DFT Fringe does, with an image of an optical flat and a fringe pattern, it will turn it into an interferogram. One of the things I'm doing is setting up next to my lapping area. I'm going to have a measurement area, and it's just going to be dedicated to doing that. So you don't need anything super fancy. I'm going to be using a high-quality webcam suspended over the work area so that I could put the thing in, hit the button, take the picture, and submit it to DFT Fringe for analysis, keeping a very nice tight loop. Here we go. Robin just posted a picture comparing my smaller optical flats to my 14-inch optical flat. I think that was sort of a left-handed flex. Was that a bit of a flex there, Robin? I think that was a little flex there. Oh, Robin said something funny to me, and you can see the nice fringe pattern in there, right? Robin, we were talking, and Robin says, "You're going to need the big Kim wipes." And I'm like, "Yes, sir." So Robin sends me the order number for McMaster Car to get the big Kim wipes, which I posted a picture of, and I did. I got 2 boxes of the big Kim wipes for the big flat. Everything starts getting big. It gets out of control here. And Robin, I don't know, have you used the DFT Fringe software? Because it's, once you figure out how to use it, it's actually pretty cool, and it's not a big investment. All right, we'll talk. We're going to talk because I think you'd enjoy this. So I think you're up to date on what's going on here in Flatland, in the Flat Cave. New optical flat, new laps, going bigger, or going home. Practicing thermal control now, being very cautious about thermal changes, working in the basement where the temperatures are more constant. All these things are happening in order to do these 6-inch jobs, which I think are going to come out great. So if you have any questions, pop them in the chat, because otherwise we're going to start wrapping things up. I'm just checking my checklist to make sure we did all the things. And I think we did. We did all the things. And if you're one of the 4 people who won the McMaster Car Catalog, triple flex. It's a triple flex, Robin. If you're one of the folks that won the McMaster Car Catalogs, I will be reaching out. How flat is the new flat? Details to follow, Evils. I have the interferogram, but it's pretty darn flat. But of course, it's not as big as Robin's flat, so I don't know. I'm feeling a little inadequate now. Well, one of the tricks, I forget who brought this up. I think Robin might have brought this up, that if you get the official number, by the way, the official numbers on it are lambda over 23 on one side and lambda over 24 on the other side. That was the official result on my interferogram. One of the tricks is if you buy a lambda over 20, which is sort of a standard spec in a optical flat that's big, but you're doing small work on it, then you actually have, across that smaller work, you actually have a better spec. Because if you have to hold lambda over 20 across a 14-inch optical flat like Robin has, then in the middle you're going to have even better performance. Robin says roughly 0.5 micro inches or millionths, and that's about, they call it a millionth total deviation, I think. So that's 1 micro inch total deviation. Anyway, so stay tuned. We're going to have some fun stuff, and I'll tell you, moving around the big flats and the big laps is going to be very interesting. They're 17 pounds, so yeah, it's going to be more horsepower. Well, that does it for me. I think we covered everything. It's Father's Day, and you're probably at a barbecue listening to this on Tuesday. You are forgiven. We'll be back next week. I hope you enjoyed last week's visit with Adam Balog. Wasn't that fun? That was a good time. We have more goodies in the future. More folks coming in to talk to us. And there's one person who I'm thinking of that I want to get in here who is in the optics business. And that would be a lot of fun. In the meantime, enjoy your barbecue. Enjoy your Father's Day. I hope you guys have a good time. And we'll see you next week. Get flat, stay flat, and we'll see you in the flat cave next Sunday. Take care, guys.